Hey there, everyone. Welcome back to our channel. I'm so glad you could join us today. If you're interested in artificial intelligence or machine learning, you're in for a treat. Today, we're diving into the fascinating world of recurrent neural networks, or RNNs for short. Whether you're a beginner or someone with a bit of experience, I promise there's something here for everyone. So, let's get started. But before we go deeper, let me ask you a question. Have you ever wondered how machines can understand and generate human-like language? How do they predict the next word in a sentence or recognize your voice? Well, RNNs play a crucial role in that process. So, let's explore what they are and why they matter. Recurrent neural networks, or RNNs, are a special class of artificial neural networks designed for processing sequences of data. Unlike traditional neural networks, which assume that inputs are independent of each other, RNNs take into account the order and context of data. This makes them particularly well suited for tasks involving time series data, natural language processing, and even music generation. So, how do RNNs work? At their core, RNNs have a unique architecture that allows them to maintain a hidden state. This hidden state acts like a memory, enabling the network to store information about previous inputs in the sequence. Let me break it down further. Imagine you are reading a book. As you read each word, your understanding of the story builds upon the previous words and sentences. RNNs function in a similar way. When processing a sequence, they take input at each time step, update the hidden state, and produce an output. This allows them to capture dependencies between elements in the sequence, no matter how far apart they are. Let's look at an example to clarify this concept. Consider the sentence, "The cat sat on the mat." If we want an RNN to predict the next word after the cat sat, it needs to remember that cat is a noun and perhaps related to sat to make a sensible prediction. In this case, the model might predict on as the next word. This ability to remember and leverage context is what makes RNNs so powerful. But RNNs aren't without their challenges. One significant issue is the vanishing gradient problem. This occurs during training when the model struggles to capture long-range dependencies due to the diminishing effect of gradients as they propagate back through many layers. As a result, RNNs can have difficulty remembering information from earlier in the sequence if it's too far back. To tackle this problem, researchers developed specialized types of RNNs, such as long short-term memory networks and gated recurrent units. LSTMs introduce a mechanism called gates, which control the flow of information. They decide what to remember and what to forget, allowing them to maintain information over longer periods effectively. GRUs, on the other hand, are a more streamlined version that combines the functionality of LSTMs into a simpler structure. Now, let's talk about some real-world applications of RNNs. One of the most prominent uses is in natural language processing. RNNs are used in language translation systems, chatbots, and even voice assistants like Siri or Google Assistant. When you ask your assistant a question, it analyzes the sequence of words you've spoken, considers context, and generates a response based on its understanding. Another exciting application is in generating text. RNNs can be trained on large datasets of text and then produce new content that resembles the training data. For example, researchers have developed models that can generate poetry or stories, crafting sentences that flow logically from one to another. Imagine getting a poem written by a machine that feels like it was penned by a human. RNNs are also making waves in the field of healthcare. They can analyze time series data from patients, predicting outcomes based on previous medical history. This can aid in early diagnosis and personalized treatment plans, revolutionizing patient care. The world of finance also benefits from RNNs. They are used for stock price prediction, where historical price data is analyzed to forecast future trends. By understanding patterns and sequences in the data, RNNs help traders make informed decisions. In summary, recurrent neural networks are powerful tools for processing sequential data. Their ability to remember previous inputs makes them ideal for tasks involving language, time series analysis, and much more. While they have some challenges, innovations like LSTMs and GRUs have made them even more effective. To wrap things up, RNNs are a remarkable part of our AI landscape, enabling machines to understand context and sequence in ways that closely mimic human cognition. If you enjoyed this video and found it informative, please give it a thumbs up and share it with friends who might be interested in learning about AI. And of course, don't forget to subscribe to our channel for more exciting content on technology and machine learning. If you have any questions or topics you'd like us to cover next, drop them in the comments below. Thanks for watching, and see you in the next video.